Hi guys, in this video I'm going to talk about 4 distinct ways to do context engineering. Context engineering is the new paradigm to work with AI agents, and it is effectively replacing the prompt engineering. So without further ado, let's jump right into it. Welcome everyone to the channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Pedram, I have a PhD in computer science, and in this channel we talk about AI and machine learning and how we can use it in order to improve our efficiency. As you may already know, context engineering is the new effective way to talk with AI agents, and particularly you can achieve the task that you want to achieve for the very long-term and multi-turn interaction with LLM. In this video, I'm going over the very interesting article recently from LangChain that talk about 4 distinct ways of doing context engineering. It might be a little bit daunting for someone that is starting AI engineer to understand how to work with it. So in this video, my goal is to make it easier for you to understand and distinguish between the different components. First, let's talk about the motivation of why basically this context engineering is important. The first and obvious one is that as the problem that we want to achieve with AI gets harder and harder, we want to own the context or the information that given to the LLM, so we get the results that are not ad hoc and not basically get sometimes good, sometimes bad, or basically get a lot of time to get to the final result. Now, this basically means that we don't want to pass all the information that we have into the LLM, because obviously it will have a lot of cost for us and also doesn't give us a good information. On particularly why it doesn't give us a good information, we can take a look at these different ways that exceeding the context can actually cause the problem. We have context poisoning, context distraction, confusion, and clash. So not necessarily having all the information and passing to the LLM can result in good result because it has all of the required information. That's basically not true. Let's take a look at here. On first turn, we have a tool call and get a human feedback and a system message, and we get the response of the LLM. And on turn 2, we do another tool call. And let's say that tool 1 and tool 2 are very much completely different tasks. And now, if I'm just naively try to augment the context, all of the interaction together and pass it in here, then on the next call, it is getting some irrelevant information. Now, you might say that, okay, so it is not important to get irrelevant information, but it's not deterring the performance. But what if what happens in turn 2 had actually some hallucination and some problem? So this is the problem of distraction, the LLM. And on the other side, if this turn actually goes larger and larger, let's say in very large history of conversation, we get a lot of non-important and noisy input, so the signal to noise ratio actually goes very high, and then the LLM cannot actually provide a good result for you. LangChain actually provide 4 different categories, which I think is actually very true, and kind of encapsulate one of the most important agents. The first part is about writing context, how we can write an effective context, then how to select them, we don't want to dump everything at once, and then about the compressing the context, and lastly about the new idea of isolating context. So writing context means that we want to save the context window to help the agent perform the task. So this is basically very intuitive, and basically the whole idea of having an agent is basically this. But LangChain basically divided into 2 different categories, the scratchpad and the memory. So a scratchpad is basically when you want to have some information per persistent within a session with LLM, and the memory is something that you want across different sessions. So basically, when you leave your LLM, you come back, you want to have that information. When you have this cachebag, you can store it inside a pydantic model or a state model programmatically, rather than like saving it inside a place in your, for example, directory. It can be programmatically saved. That's how LangChain actually implementing. They have some state in each time, and then you can travel into the different states and you can read or write to it. But having this capability or a state that is consistent throughout your turn is actually really helpful, because you can keep track of what you have accomplished and what you have done, and you can retrieve the relevant information for yourself. And then we have obviously memory. So memories, as we said, for the different threads, and if we want to give new context and we want to still remember our existing memories. On number 2, we have selecting the context. So basically, selecting context means that you want to pull the information into context window to help the agent perform the task. So it's not that you bombard it with the information or all the things that you have, but give them the most effective one that is required to actually make the decision. So again, we have the cachebag, as we mentioned, that is basically a state on within the session, and then we have memories. This include like the different tools that you have, or different type of memories that you have. So as we mentioned, we have 3 different type of memories: semantic, episodic, and procedural. So it's very much dependent on the type of the memory, the way that we want to retrieve the information. So for example, on semantic, we're gonna look at semantic similarities, but for episodic, we can't just look at the semantic similarity. We need to create like an orchestrator that decide which one are relevant for us, or for example, some idea about the time dependency, like for example the experience that happened a lot long before might not be relevant right now. And then we have procedure or instruction, which basically the motor skills for the task. We might have so many different skills that we have. We don't necessarily want all of them. We want to achieve and retrieve the most information that are related to this specific task and not the other one. So that's why they mentioned some of the very most popular coding agents, such as like Cursor and Windsurf, and they mentioned that they are not just going to pull the context based on the semantic similarity, because on that case, then you're just going to take a look at some part of code that's retrieve some part of code and not the block of the code or some meaningful chunk of the code. So basically, chunking strategy will come into play, and some other specific nuances ways are required to basically retrieve the specific information, such as for example knowledge graphs and so on. So these are actually related information in terms of the memories. And then we also have tools which basically are the different capability that the agent have. There is a recent paper in here that actually talk about if you have the number of the tools for the LLM more than 30, from 30 it actually try to get some results wrong and don't provide or call the correct API, and in 100 it actually try to just fail and collapse and don't get the good results. On number 3, we have compressed context. So compressed context is actually relatively important, because what we want to do is that if the number of turns actually goes larger and larger, you cannot fit all of the experience in. So basically, if you work with Cloud, it actually, after it reached the 95%, it automatically applied the auto compress, which basically summarize what has happened so far. And usually, for me, what happens is that when the context get actually too large, the agent cannot provide and be as effective as it is when the context window is actually relatively lower. So for those kind of cases, when we are doing this summarization, it's important, like what information are we gonna miss, what information are we gonna summarize, what we are going to save. And so there are different type of compression throughout the trajectory of agents. There are recursive, hierarchical summarization. There are so many work on how to choose the effective one, but basically it is important that we choose for certain tool calls, for example the one that are token heavy, we want to somehow make it separate of the actual LLM. So if you take a look at in here, when we are doing the summarization, we don't necessarily want to keep track of actual for example token heavy size for the tools itself. And then the other way is actually context streaming, which you basically effectively try to get rid of some of the context that you think is not important or relevant anymore. So basically you prone those contexts. And the last but not least is isolating the context. So this is actually a very important idea in here, and comes in the context of multi-agent. When you have a task and you want to have multiple agents in order to complete the task, so you can divide the task into subtasks, and each agent actually try to do a subfield of that task. And basically by this you can kind of increase the context size, because each of the agents only have access to a subset of that context, and basically if it is cloud, like we have 200,000 here, 200,000 in here, 400,000 in total, so on. In theory you can basically double or even more your context size with multi-agent, but it's very important that you choose these isolated with the tasks that have the least number of interaction with each other. And then we have like other ideas like swarm and multi-agent researchers that try to achieve these tasks. There's also very nice concepts from Hugging Face Deep Research that try to mention that how we do the code environment execution is that they completely separated the execution environment from the agent itself. So the agent just works with a code to execute. So you give the code to this sandbox, it will have all of the relevant information, all of the states and so on, and it retrieve the result, and at the end it just return the values, the std out, the variable names, or whatever that is important. And there you have it, guys. We went over 4 distinct way of doing context engineering, from writing the context, selecting the context, isolating the context, and compressing the context. If you enjoyed this video, make sure to like, more importantly subscribe to the channel so you see more videos like this. And you can watch this video that I talk about context engineering in general, and I actually do a demo on it, or you can watch this video that I talk about Gemini CLI, the new way of working with Google powered AI. Thanks for watching, and see you until the next one.